That's called manual. This is called system packages take care of the work. Are you clear? All right. Now let's go ahead. Standard scaler. So what happened right now? We scale the data. Once we scale the data, why train, why test? Let me repeat again. Yesterday, what we started, because some of them students joined now. What we started today, yesterday we complete logistic regressions, math, sigmoid functions, logit, maxent, probability greater than zero, less than zero. We understood all those things, guys. All right. And today we considered one data sets ranges. Yep. So today we considered some of the packages numpy, matplotlib, plt, and pandas. Now I call the data. So this is the data sets I have. Assume in the historical data, some of the customers that purchased the four-wheelers vehicle, isn't it? And these are the records, their user ID, the gender, the age of the customers, and the salary of the customers. And does customers have purchased the vehicle or not? These things, historical, previous data we have. And always we need to build the model on historical data. Today, all these things we clear. We build the model on historical data, guys. Now that's what I'm doing. What is the next step? I'll come back to you. So first I call three packages, numpy, pandas, matplotlib. I call the data set, and in this data sets, user ID, gender doesn't decide whether you purchase the vehicle or not, isn't it? So that's why I'll eliminate these attributes from the data sets, and I split the data into independent and dependent variable. Once we split the data into independent, X has split into X train X test, and Y has split into Y train Y test with 25 percentages. So out of 400 records, 300 records goes for X train and Y train, and 100 records goes for X test and Y test. And after that, we've been scale the data. What's meant by scaling? So have a look at this. So in the data sets, system does not understand age and salary. Both are different attributes, right? We need to make the system to learn that both are different. And how do you learn? By apply feature scaling. And we have a scaling techniques called standardizer, okay? Normalizer and standardization. So here we take standard scaler. Once we go ahead and apply standard scaler, we apply the technique to X train and X test. So what happened finally? We scale the data. How this negative comes up? Negative comes because the formula when you implement the negative values we get, isn't it? All right, so let's close this. Up to this clear. The next one, let's build logistic regressions. Before I go ahead to the logistic regressions, logistic regressions also I'm calling from sklearn.linear model import logistic regressions. I create a identifier LG equal to, this is object which create the logistic regressions algorithms, isn't it? So here, the moment when I click my cursors over here, and do you see, let's discuss about the parameters. Penalty L2. Which penalty is a lasso ridge, guys? Lasso ridge. So in ridge, do we reduce the coefficients to zero? No, it up to zero, but we don't. And then fit intercept true, class weight none, random state none, solver LBFGS. So let's go back. Do you see logistic regressions, aka also called as logit and max and classifier? Yesterday I told you or not? Now, this own tells you a lie, because we try to find out the maximum of all the data points from both sides. So that's why max of yi into wx, so that it's always greater than zero, isn't it? So based on the maximum applications, we need to consider the max and classifier. Are you guys understand? So here, what is hyperparameter tune? If I change L2 to L1, if we change L2 to L1, we get some accuracies or not? Where is between accuracies? And then solver LBFGS. If you scroll down, what is meant by solver? So just scroll down parameters. How many penalties we have? L1, L2, and elastic net. So by default is L2. Now, if I didn't teach you regularizations, will you understand logistic regressions? Will you understand hyperparameter tuning? No. You see this data set in many places, but understand the parameters are important. While you work in organizations, if your accuracy is not up to mark, you change these parameters. Understand? Still you not exist, then what you do, go to the data sets, do data cleansing once again, choose right relevant attributes, and do repeat the same things once again, guys. Scroll down. And here, I hope no penalties added. L2, L1, you know this. What is the next one? And I will talk about another one. The two parameters, very important, and these things you don't need to go in detail because some of them are inbuilt functionalities. No need to dig it down more, and don't want to be a research on this. There's two things: research and apply jobs are different aspects. Research, I don't want you to be digging down of each and every parameters. I said these two parameters important, just follow that, that's it. Are you guys getting me? Now just scroll down. So this one, penalty, and this one solver. What is meant by solver? I'll scroll down, scroll down, scroll down. Okay. So how many solvers we have? And SAG, SAGA, lib linear, and all the solvers we have. Let's copy, and I'm going to paste in this one. So understand why we called logistic regressions logit and maxen, guys. Okay, so here solver, how many solver we have? Newton CG, LBFGS, lib linear, SAG, SAGA. So little bit light on this. These are algorithms to use the optimizations problems. I hope you understand what is gradient descent. Gradient descent is an optimization algorithms. It reaches to the global minima, isn't it? So what is meant by optimizations? If your error is 70, the moment when you optimize it increase to 80. When you optimize, the 70 to increase to 85, the 85 to 90. The moment when you optimize, the accuracies keep on increase. So right, that's called global minimum. So algorithms to use default is LBFGS, isn't it? For small data sets, lib linear is good choice. Are you getting my point? And then whereas SAG are faster for larger ones. When you in the real time, if you got one of the data sets, I will show you my one of 10M students. He got one interview from one company. I want to share the data sets, guys. Okay. And then you get to know. Can I share you a little bit? I just open up and I'll show you what kind of questions you might encounter in upcoming days. All right. And then lib linear is limited to one versus rest scheme. So there are two type of classifier, one versus one and one versus many classifier, one versus one and one versus many classifier. So all those things, or one versus rest or many, we can call this multiple things, guys. So just minimize. Are you clear? So I hope understand. So what I'm going to do, I don't talk about much because we already know what is stochastic average gradient descent, SAGA solver. These solvers follows gradient descent in the back end. So sklearn is popular because inbuilt functionalities of it. Understand? Now here, see guys, understand theory. A lot of people explain very nice way. That doesn't important, right? So you have to go and dig it down, and when you practice, then only the things works out. Do you remember? I'll come back to this one by one. So here, let's go ahead. And when I say logistic, let me execute. Let me call my algorithms from sklearn.linear model. And I create an object for logistic regressions, which is classifier. For regressions, we build a regressor. For classifications, we build classifier. So how to build the model? If I fit this algorithms to my training data, then we built a model or not. So how do I classify it? Means whatever the parameters we have, I am trying to parameter fit those parameters to the historical data, and just go ahead and check this, and we build my models, guys. So now check classifier. When we check, this is logistic regressions algorithms. In logistic regressions, what was the penalty by default? It's implemented L2. What is the penalty? L2. Clear? Now, let's go ahead and predict X test. Now let's compare. I create a predictions table, classifier predict X test. I want to compare Y test and wipe red. So actually what happened? Actually, this is zero. Customer not purchase the vehicle. My model also predicted customer does not purchase. Seventh one, customer purchase. This is wipe red, means this is predictions table. This is actual table. I'm comparing Y test versus wipe red. So if you comparison, there is a ninth record. Actually, customer does not purchase vehicle, but my model predicted customer purchase. Misclassifications happened or not? I wanted to know. I wanted to know how many records are misclassified like that. How many records are misclassifications happened? So that's why we need to implement confusion matrix. What exactly we matrix, guys? Confusion matrix. So how do we call confusion matrix? So very simple. From again sklearn dot matrix import confusion matrix. So in confusion matrix, how many part we discuss, guys? Four. What are those? TP, TN, FP, FN. Now I wanted to predict. Do you remember TP, type 1 error and type 2 error? All those things we discuss. Now, as I keep on saying, I'll call the confusion matrix. Once I call the confusion matrix, all the time I wanted to build the matrix on Y test and wipe red. Where exactly, guys? Every times we need to build the matrix on Y test and wipe red. So once we build, let's go ahead and see. We generate one table or not? Did you see this? Now let's copy this and I'm going to paste here. Anyone tell me which is TP? What is TP, guys? Online team 65. Can I say what is TN? What is TN? Online team, are you there? 24. Very good, Yamini. So 24. What is FP? 3. What is FN? What is FN? 8. Okay. Can you tell me what is accuracy formula? 65 TP by TP plus TN by total. TP plus TN plus FP plus FN. If I solve this, what is the accuracy now? 65 plus 24 divided by 65 plus 3, how much, guys? 68, 8, 76, 24, 100 is equals to 89 by 100. What exactly accuracy I got now? How much percentages, guys? 89% accuracy we got. Do you see how the confusion matrix implement in the real time or not? To find out accuracies, what exactly we need to do? From sklearn.matrix import accuracy score. Just go ahead and we can also implement this one from sklearn.matrix import accuracy score. But here 65 plus 3, can you please tell me which is error? Which is error? How to compute the error part, guys? What is other equation? So what is FP? Very good, Sashi. So 8 plus 3. So 8 plus 3, 11 by 100. So what exactly, guys? So here 11 records or not? So 11 records misclassified happened. How many records misclassified happened? 11 record. So if you see the test is 100 record or not? So if you combine all those things, so 65 plus 3, 68, 8, 76, 100 records. Are you getting me? 1 minus accuracy. So definitely 100 minus what is accuracy we got? 89. So 11 or not? So 11 records misclassified. 89 records proper classifications happen. That's why the accuracy of the model is 89%. Are we clear or not? Next one. So how to check accuracies? Import accuracy score Accuracy score Y test and Y pred. When you build this, what is accuracy we got, guys? 89 percentages accuracy we got. Classifications report. So how to build the classifications report? To build the classifications report is the package calling from sklearn.metrics, sklearn.metrics, sklearn.metrics. Same, always you need to build on Y test, Y pred. But if you see these reports, do you discuss on yesterday or day before yesterday what is precision, what is recall, what is F1 score, all those things? Are we get this data or not, guys? What is precision? TP by predicted, yes. Recall TP by actual, yes. So I hope understand, guys. So this is the classification report we build. Understand, team? So what we done right now? So we got 89%. But before that, before I go ahead and I can talk about this. So classifications does not require any visualizations, but still classifications does not required any visualizations. Why? Because if you write exam, if you scored 85 percentages, do you think visualization required? Does not required, isn't it? But still visualization is not required. So we required AUC and ROC curve. What exactly we required, guys? AUC, and what is AUC, ROC? I'll come back later. So, but here, assume I'll try to plot one of the techniques here, visualization the test set result. When we plot this one, I'll show you just one moment. Copy and paint. So if you see this, so let's predict TP plus type 1 error and type 2 error. 8 plus 3, 11 or not, guys? So I mean to say in red zone, the greens are error or not? And in the green zone, the red point is error point. So let's compute 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So are we clear or not? So 11 records are misclassifications happen because yesterday math equation, this point y into wx is less than 0 or not? And all these points are greater than 0. 1, 2, 3, 4, because this data points does not match the conditions. So that's why this is misclassification record, and the accuracy of the model is how much percentages, guys? 89 percentages we have. Understand? 89 percentages we have. Now we build this one. We build the confusion matrix. Do you remember what is bias and variance? What is bias and variance? What is bias and variance? Anybody, guys? What is bias? What is bias, guys? Overfitting means low bias. Bias refers to training or testing. Bias refers to training or testing, guys. Training. So what I'm going to do, I will add a new formula. Bias equals to, what is the name of the model we built? Classifier dot score. So here, training. So what I'm going to do, let's scroll down. Classifier dot score. We build the model on X train, comma, Y train, isn't it? So classifier is the logistic regressions model. We build the model on X train or not, guys? Now let's go back and let's check bias. So let me run this. What is bias we got? 82 percentages. What is the bias we got? 82 percentages. Now let's talk variance equals to classifier dot score X test and Y test, and then variance. So when we do this, what exactly happened? 89. I mean to say that low bias, high variance, overfitting or underfitting. So listen to me. Accuracy, I got 89 percentages. Bias, I got 82. Variance, I got it. My question, Is it good model, or the model is overfitting, or the model is underfitting? How's your response? Good model or the model is overfitting? Online team. Sashi said overfitting. What about others? Now, let me say, when you write an exam, one of your friends got 89 percentages, you got 82 percentages. Do you think it's overfitting, or the both in lies on same? It's not overfitting, guys. Why do you think it's overfitting? So what is meant by overfitting? I'll give you some of the situations. Do you think if you write exam, you got 89 percentages, one student got 82 percentages, one student got 80 percentages. Now you got 89 percentages. One student got 70, or maybe I can say 54. One student got 65. This is overfitting, not this. Are you clear or not clear? Yes, Arjun? Yes, online guys. I hope you're clear. No, this is not low bias, guys. Now I can say this. Definitely, we have some distinctions parameter or not, 80 to 90. I give you example for this one. Please understand. So this case is, what do you expect? Do you expect accuracy 89, bias also 89? This is also 18. Never get it. No Google data scientist can also done this. Remember it. Are you getting my point or not? What I'm trying to say. Machines varies. In news, they said tomorrow the weather is 50-degree. Do you think 50? It would be ups and downs, 45, 46, 55. Are you catch my points? What I'm trying to say. So let's go ahead and now let's minimize this one. So go to this one. Very simple. Today we build logistic model with accuracy 89 percentages. Now let's go ahead. We build logistic model with 25% test data, 25% with feature scaling. With feature scaling, what is my model predicts, guys? And model accuracy is 89 percentages. Bias is 82 percentages. Variance is 89. And we found this is a fantastic model, guys. I can mention as the model, good model. What is the next step? Okay. In many of the institutes, in Kaggle also, they will stop here. They build the models, they stop here. Nobody tell you what is the next step. I will tell you what is the next step, how this implement in future. But before that, okay, so what is accuracy I got? And also I wanted to write down, if accuracy is 89 percentages, bias is 56 percentages, variance is 80 percentages. On this scenario, we call as model is overfitted. Model is overfitted. When model is overfitted, no, you won't consider this. You won't consider this for future predictions. I hope how to decide if model is good. Very simple, man. Arjun, come on. If you write exam, if you get 90%, definitely it's a good. And to check this, that's what I'm giving you these examples. Let's say if AC is 89 percentages, bias is 89, bias is maybe 85 percentages. If variance is 55 percentages, what we call the model is underfitted or not? The model is overfitted, the model is underfitted. If you got accuracy is 89 percentages, if bias is 80 percentages, and if, sorry, 80 percentages, and variance is 80 or maybe 79 percentages, this is good model. The reason why, so what I said, low bias, high variance. Can I say this or not? On this case, okay, high bias, low variance. This one, low bias, this is called bias variance trade-off. Now got it, Arjun? This is example. Are we clear or not clear? Are we clear or not, guys? When to check good model, when to not to check good model, how to check the model is overfitting, how to check the model is underfitting. Practically everybody understand or not understand? No Kegel, let's give you this one. Understand? So I want you to understand this part. Okay. So look at this first point. We build logistic model with 25% test data. With the feature scaling, are we done? Are we done feature scaling? In feature scaling, what we done, guys? Accuracy 89%, bias 82, variance 89. It is a good model. Now let's do logistic model with 25% test data without feature scaling. Shall we check this, guys? What is feature scaling? If I'm not do feature scale, so let's go around. What is mean by that? That means I will inactive it. I'll use my multi comments. So this code is inactive now. And if I click it, do you see the code is hidden or not? This PySpark is very good for debug issues, guys. I hope you guys know about PyCharm debugs, guys. So the same way, did you see the if I click this, the code is expand or not? The code is expand, guys. If I click in here, the code is not expanded. It's hidden over there. So the moment when you click it, it's going to be expand, isn't it? So here, what happened? So when I inactive this, this code is won't run because now I'm going to build the model without feature scaling. So without feature scaling means extrain standard scaler not implement. So just go ahead and we apply the NumPy pandas matplotlib. We call the data and we split the data into independent variable. We split the data into dependent variable. Now train test split, we split the data into xtrain and xtest, ytrain and ytest. Same thing. So I'm not going to use this. In last, I scale the data or not? Here, I don't want to do any scaling. Just directly build the model. All right, guys. Just directly build the model. When I directly build the model, okay, let's predict the x test here. Let's build the confusion matrix now. Anybody tell me what is accuracy of the model, guys? 68, isn't it? Let's go ahead and we check this. The model accuracy is 68. Is it good model, guys? Do you think 68% accuracy, do you think the client will accept? No, not at all. What is bias? Let's go ahead and bias 63. Variance 68. But still, bias variance fine, but accuracy is not good. Are you getting my point? So without feature scaling, accuracy is 68 percentages, bias is 63 percentages, and variance is, we need to improve the model. We need to, guys, are you understand or not? So this is no one is accept. Online team, are you clear or not? Ranjit, why we talk about lambda here? See, why you apply median? See, I mean, are you wanted to show that you're good at code or what? I mean to say that we are discussing on Goa trip, but you're talking about yesterday's dinner, which does not make sense. Understand? Are you clear, Ranjit? So what I'm trying to say, okay, no, no problem. What should be minimum accuracy? Minimum accuracy is 80%. It's acceptable across the globe. Minimum accuracy is 80%. If it is startup projects, R&D projects, you has to be improved to 90 percentages. In text mining, it's very hard to reach 80% accuracy. I will get back to you all those things. Okay, Ranjit. Now, next one. So, guys, are we clear? So the two things we done: logistic model, 25% test data with feature scaling, without feature scaling. Do you see? Now, go ahead to the next one. I wanted to build logistic model with 25% test sample with feature scaling normalizer. We have two techniques or not? Standard scaler and normalizer. Let's see what exactly the model predicts. Guys, listen to me, because today I will give you in detail only one algorithms I can explain. Next time onwards, I'll give you to do the task. You can do the same process, right? Now, what I'm going to do, I will, I'll remove this one. And are you getting me? I will change this to which one? Normalizer. Okay. Let's copy. Are you guys clear? Now, file, save. Let's call the packages. Let's read the data frame. Independent variable, dependent variable. Import train test split. Then this one, I will scale normalizations. When I use normalizations, did you see all the data ranging between 0 to 1? There is no negative now. There is no negative now. Let's close this. X test. Now there is no negative, isn't it? Now let's close. And we try to build the logit model now here. Let's go ahead. We build the model. Let's predict the X test. And I want to build the classic confusion matrix. So what is accuracy we got, guys? 68 percentages. What is accuracy we got? 68 percentages. So by default, it's standard scaler. We change to accuracy is 68 percentages, guys. Are we clear? And don't talk about bias. And yes, we do have debugger. So that's why I said, right? I mean, you can check this, you can click out. I just hold this one and you can write an individual. You have a debugger like this. Clear, Ranjit? I want you to click, select the line, and you can debug it. And I hope even though you run, you can find out the specific code. Okay. Yeah. So just let's click it. All right. Now the next one. The next one is normalizations. Got less accuracies or not? Normalizations got less accuracy. Now, what is the next step is random state. Let me tell you, what is difference between if I change the random state here, I remove random state from at the time of split the data. So let me save the model. So file, save. And let's restart the kernel. I import the data set. Okay. When I split the data x3 next is randomly the records are split or not? Okay. So what happened? The moment when we do every run, separate records will choose, guys. I mean to say, what is the impact? Let's assume you build the model and you can set up a meeting with your management leaders and your FLMs, and you drop a message, sir, I built the model and we got 90% accuracy. Now, everybody's need to be more enthusiastic. What is meant by model? They do want to know. So by the time when you want to present this one, by mistake, you remove random state equal to 0. Once you remove, I wanted to run entire code at once. Do you see this play button? Run this. So when you run this, what exactly happened? Accuracy, how much got? 62. Now what happened? In a mail you mentioned I got 89, but in front of everybody, you say 62. Why? What is the reason? The reason is, if you see the X train, so we have, sorry. So the reason is X train, we have all these records has been selected, guys. Okay. But before that, I want to change to standard scaler. Okay. Just one moment. Normalize it to standard scaler. Now let's restart the kernel, because the every run, what happened? The records will be changing, guys. So that I mean to say, let's just 1 second execute this one and call the data frame, split the data into independent variables, split the data into dependent variables. Now train test split this one. Okay. Now have X train 23. Now X test. I will take 1 second. Let's minimize snipping tool. New. So in the first run, the machine selected these records or not. Once we build the model like this, let's close and run everything at once. Just have a look at it. Accuracy, I got 87. Accuracy I got, but in the mail we mentioned 89. Bias 84. Variance, that's okay. But your manager said, okay, somebody, can you please rerun again? Your manager said, can you please rerun the code again? So I'm doing the rerun once again. So just have a look at it. Once we rerun, now go to Xtrain, or before Xtrain, I'm sorry. I think let's do restart the kernel. Just give me a moment, guys. Team, I hope you understand what I'm doing. I'm trying to explain the different parameters to accuracy fluctuate and what is the reason behind the accuracy is not increase and the decrease. So if the accuracy is not up to mark, you to do change all these parameters, guys. So let's numpy and read the CSV file. Oops, I'm sorry. Read the CSV file and independent and dependent variable. And then I'm going to split the data into Xtrain and Xtrain, Xtest, and Ytrain, Ytest. Xtrain and Xtest. Now, this records, previous record, does it both are same or different now? So what exactly happened? Every run, the accuracy will varies or not varies. This would be a problem. This would be a biggest optimizations problem. So that's why I want you to pass everywhere like random state equal to 0. Also, there are 3 random state, guys. You can check with random state equal to 0 or 41 or 51 or 100. Will you do this, guys? So in this run, I make random state to 0 and let me know what is accuracy. Let me know what is accuracy for each and every random state change to 0. Mention some accuracy. Random state 41, check some accuracy. Random state 51, check accuracy and update me. Clear up to this? Up to this clear? Another one. So if you remove feature scaling, are we get less accuracies or not? Now let's restart the kernel. So assume so far we found this is the best one, 89 percentages. Now your manager says, I want you to please add 1% accuracies because it's a new startup projects, guys. When you do 90 to 90 above, you will get more client and it would be acceptable by client. That's called research projects, guys. So research projects means R&D, POC. POC means every organization has a POC, proof of concepts. You said in my organizations, I implement ML models and we build all those things, guys, right? So what you do, the next one is how to increase the percentages 89 to 90. On this case, I wanted to do please reduce the test sample 25 to 20. Please reduce the test sample 25% to 20. So once you reduce the test sample, so file and save it. Oops, file and save this. Once we save, what happened, guys? Let's go ahead and do one more time. NumPy pandas matplotlib. I call my data set and remove irrelevant attributes. This would be independent variables. This would be dependent variable. This would be dependent variable. This would be independent, age and salary. This would be your customer purchase car or not. And then I split the data into, I'm in training testing phase. Let's split data into 20%. 20% means 400 into 80 by 100, 20 by 100 means 320 goes for train, 80 records goes for test, isn't it? Feature scaling is must, then only the accuracy will increase. So which algorithms does not require feature scaling? I will tell you three algorithms does not require feature scaling. What are the three algos? It's a long story. I'll come back to you later. So feature scaling is done. Once we do the feature scaling, let's check extrain. Are we scaled or not? Feature scaled. Now let's build logistic regressions algorithms. And I create a classifier for this algo. And let's fit into X train and Y train and then predict X test, guys. Now, what is the next one? Let's build a confusion matrix of Y test and Y pred. Can you please tell me what is accuracies now? Excuse me. What is accuracies, guys? Six misclassifications. That's correct. Out of 94. Arjun said 57. Guys, apply the formula, man. Why are you saying blindly? Apply the formula. Then you tell me what is accuracies. 5750 divided by how much? 100? So very simple here, 57 plus 17, 74 percentages. Everybody's wrong. Just now I said to formula 57 plus 1, 58 plus 5, 63 plus 70, 80. Look at this, the test is 80. So here 57 plus 17, 74 by 80. How much percentages, guys? Very good. So let's apply the accuracy calculations. When you say this, 92.5 percentages we got. Team, are you getting me or not? How much accuracies we got? This is good model or not now? But let's check. Let's check how to check. If I got my bias between 80 to 90, that's good model. If it's go beyond it, then that's not a good. So Jeff, have a look at this. Fantastic 82. And then variance, almost the data is clean. So that's why we have 92. So guys, are we increase the accuracies or not? So logistic model for 20 percentages with standard scaler, the accuracy is 92.50 percentages. Bias is 82. Variance is 92. This is what maximum accuracy we have, guys. We cannot increase it. That's good enough. Don't you think 92 is good or bad? Machine learning model never gives you 100%. Remember this. So when you write any entrances, how many students get 100 out of it? Very less. Understand him. So that's why machine learning model never gives you. Now, online team and offline team, 8:30 a.m. batch. Are we clear? But another one, I wanted to do logistic model with 20% with standard scaler with hyperparameter tuning with L1 penalty and solver LBFGS. LBFGS. Can we do hyperparameter now? Try this. No, you cannot. Then the model is biased. Understand, Arjun? So what happen if you think like that? So as much as if I go to 20%, 15% and 10%, there is no concepts of sample, guys. There is no concepts of sample. If you say, then you can take 95% train, 5% test. Model is always biased. Model always supports 95% only. There's a big story. Understand, Arjun, about this? The model is biased. Bias means what, guys? If 95 people men and 5 human, if they, I mean, have some competitions, every time it will win. So 95% is one class, 5% is zero class. It's not going to work out. Got it? Great. Now, the next one. The next one, we build the model here. And from this model, just go to the help options. I want to change the penalty. Let's copy and make it to L2 to L1, isn't it? I will change the penalty. And once I change the penalty, let's mention solver. Let's copy and here, but still we have some obligations. What are the obligations? I want to scroll down and the obligation is which penalties work for which solver is important. I mean to scroll down, just scroll down, just scroll down. Okay. So see, Newton CZ, it will work when you have penalty L2 or none. When you have L1 and if you mention Newton CZ, then we get a bug. Am I clear or not? So for example, let's copy this and run this one. Let's fit the data. We got error or not now? Value error. Logistic regression supports only solver lib linear. So if I apply LBFGS, if I mention L1, still it gives you a bug. If you talk about lib linear, let's copy. And then I wanted to talk about this lib linear. Then only it will accept. If you have, see, SAGA. Now, if I change to SAGA, then only the penalty L1 is valid. Team, are you understand? These things, none of them explain to you guys. This is in-depth understanding of hyperparameter tuning of each and every graph. When you work in real time, when you build logistic regressions algorithms, I want you to check this and then fit those things to the data. Guys, are we clear or not? Are we clear? See, many of them left. So what is the next step? Can you please try to do hyperparameter tuning? I'll give you 3 tasks, guys. For logistic regressions, I want you to build the model with, okay, L1 penalty, okay, and I show which solver based on the penalty. First one. Second is please build the model with 15% testing sample. Just now I changed 25 to 20. I want you to build testing sample with random state 0, random state 41, 51, and 100. Next one, please build the model with 20 percentages and the sample is 20 percentage and random state is we already build now with 0 and I want you to build with 41 and 51 and 100. You got to know That's the things. Can you please build three things, guys? Can you build three things? And let's see how many of them in the class and how many of them and out of the class, guys. So a Python developer, so to understand this model building does not require Python background. Just you need to remember the packages, concept, predictions. What is predictions? Also, just give me 5 minutes, guys. I wanted to tell you very next step. Let's say so far, so far we have historical data, isn't it? So far we have historical data. Historical data till today, the data is history. Can I say tomorrow onwards it is a future? Tomorrow onwards it is a future. Machines does not know all this common sense, right? Are you getting my point? What I'm saying? So I'm trying to say here, the all are same code of finding. Very good. All are same code. So now here, I want you to, in historical data only, we split the data to train, test, and predicted. Isn't it, guys? The next step is how we predict the future from the model. Which model we build? Classifier. Which model we build, guys? Classifier. Okay. Online team, are you listening me? Did you see many of them left? This is very interesting part now. So let's minimize. I have one future records, guys. What is mean by future records? Future records means in the logistic regressions, future predictions model comparison. So now these many customers give you an appointment to you. How many customers we have? 10 customers. How many customers? Today they called to let's say, Honda showroom. They called you. This customer said, I will visit next week. Okay. And I will check if everything is fine. I'll purchase the car. This customer called the Honda showroom and he said, I will visit to the storeroom by next week. Are you understand? So these customers, Honda car doesn't know whether he purchased the car or not purchased the car. I want you to predict this customer to purchase the car or not. How do you predict this, guys? So now I want you to pass this data set. I want you to pass this data sets to the existing model. What is the model we built? Classifier. Are you getting my? And once you pass the data sets to my existing model, now what exactly happened? The logit model predicts some accuracies. What is accuracies? Logit model predicts this customer purchased the vehicle. This customer does not purchase the vehicle. This customer does not purchase the vehicle. This customer purchase the vehicle. Does not purchase 0 and 1. So this is model predicts. You don't know the customer because you need to be wait for that day. Let's say the customer give you an appointment on 11th. So this customer visit to the store, and if he purchase the vehicle, what is the accuracy of the model? 100% or not, guys? If this customer does not purchase the vehicle, let's copy and I'm going to paste here. So this is model predictions versus real-time data. And this is called first level of testing. First level of testing with future data. Now, so guys, are you understand what I'm trying to say? Online team, I hope everybody's clear. So this is first level of testing, guys. What is first level of testing we done? I have a future data. Future data, there is no predictions, guys. I need to pass this future data to the existing model. But how we sure? Saurav, guys, are you listening my class or not, Saurav? I am saying, let's say you call to a store today. Okay. And which store? Honda store. In Honda store, they have data scientist. They already predict tomorrow when you visit to store, You have in mind that you'll purchase a car. The model predicts you purchase. When you go and purchase, it's 100% accuracy or not, guys? Very simple. How means what to say? That's the called real time data. What is real time data? Customer visit to the store, purchase the car. That means model predicted one. Before you visit, model already predicted, guys. That's called future predictions. In Big Billion Day, the model predicts what could be the pricing for tomorrow, what could be the pricing for day after tomorrow. That's the Kaggle challenges. That's called Kaggle competitions. So based on the forecasting, guys, are we clear? Now, can you try to do Yamini? I hope you're clear. What about Sashi? I hope you're clear. Arjun and some of the some of them. So we pass this exactly similar the test data which we pass. I want you to pass this data which you never trained before. This data which you never trained before. So how to do this, guys? Can you try this? There's a two things. I want you to research how to pass the future data. See, what will be to X and Y? Guys, Akshay, see, you go to a company, you're working as an employee. Okay. Now, manager says to work this. Will you ask to managers what would be X and Y? That's what you need to think, man. And that's why you need to do. What would be X and Y? So in previous data, just now I gave you one practical here. What did you take X and Y? Agent salary and purchased or not? Same thing you considered here. That's what, buddy. See what happened. I want you to use your brain to think and research and get back to me. If not, I will explain. You don't think I will complete, guys. I want you to little bit research. So this type of tasks you encounter in the real time. So from the database, you pull the right a query to pull the records. How many customers? They're the future. And you store the data to the database. It's a long process. Okay, if you don't want to do, leave it, guys. I will complete that. I want you to research. You try. That's what. Yeah. You have to scale. That's good question. Akshay, are we clear or not? See, estimated salary, of course, man. See, the model is built on salary. So definitely the predictions part also salary is there. But let me tell you, you need to match this records to, it's a long process, guys. It is a long process. That's what I think. If you build this, you can predict your dad's business tomorrow. Your dad's businesses get profit or loss. Tomorrow, your salaries will increase or not. Tomorrow, are you getting good salaries or not? Many things you can connect to it. Online team, are you understand? Akshay, you sit and practice the previous task, then you can apply this. Will you do this? Yes, you must need to do this, isn't it? So first level, I will come back to this more on it. Let's do this. How many of them done? If not, I will complete that tomorrow. And tomorrow we close logistic regressions algorithms. Okay, so yesterday we complete math and algos, but today we see lot of practicals, lot of hyperparameter tuning, how to increase the accuracies, how to check overfitting practical, how to check underfitting, all those things. And also the main important part is this is what real time. What is real time? I want you to pass this data to the previous model which you built. If model predicts 0, 0, 0, 0, it's a wrong predictions. If model predicts 1, 1, 1, then it's a wrong predictions, guys. You try. If not works out, tomorrow we discuss about this one. How to predict the future. So based on this, every year your company have a census forecast this year how many amount grows and what would be the profit grows, what would be the quarter 3, quarter 4, quarter. They do forecasting. Every company is forecasting, guys. They will forecast for next to next year. In the database, has anybody working on database, guys, real time? Somya, you worked in DB? The one who work, you ask that in the database, do you see next month records? next to next month records, you can ask. If you say yes, how the records come, you ask, they don't have answer. They're working, but still they don't know. Online team, are you getting me? Yamini, are you working on DBs? Anybody's working on database, guys? In the database, in the organization database, no. So Yamini, the one whoever working professionals, anyone in from database side here? Anyone from database, guys, works in DB? In the database, all the future records are stored. No. Future records means what? Customers has a connect with client. Your TCS has connect with a client for 4 years. They have capacity allocations forecasting means this vendor wants the data from next year also. All the records already been in the database. You took write a query to take the data, and I will tell you all the real time. None of the institute explained. No Scalar Academy, no such a big things, no UK institutes, no US institutes, guys, except me. That's why my people get placed. Do you understand? There are three level of testing happens everywhere when you build the model. So this is the first level of testing. I will explain second level of testing. I'll explain third level of testing. Most of people, by look at the sample data set, I know this data set, but no, guys, data set is not an important part. Executions, tunings is important. Anyway, talk to you tomorrow. I will share this code. Please work this and update me tomorrow. Let's check using same techniques. Very good, Arjun. Now got to know all. Fantastic. Fantastic. Now you can, this is very good. Now you can ask the how to they check the futures. When you also, when you also working, you got to nobody. So whether forecasting is regressions, okay, but this is classifications. But now every company has a forecasting based on the existing model. I will tell you tomorrow when you book the train tickets how machines recognize your future ticket is confirmed. For them, we need to implement Bayesian theorem. What is the name of the algorithms, guys? This is core technical, trust me. Also, I will tell you how ChatGPT works. For that, we need to learn AI. First, I'll complete ML part, then we head in toward AI. So if you till today, if you not practice, forget it. But today onwards, please work. Things will change. Are you trusting me? The moment when you join this batch, from now to this, many of us, my students, please. Now it's your turn. Make resumes and send it to me. Clear, guys? Thank you and have a good day. We talk to you tomorrow. Bye.